Okay, today we're going to finish up and we're going to do synthetic division. Synthetic division is very similar. Okay, now this is a division problem, is it not? It's just not written the same way. Now, if I wanted to do long division, I can rewrite this. Okay, y plus 5 into 4y squared plus 23y minus 16. And I can do long division. Okay. However, synthetic division is simpler, but it's got a couple of different twists to it. So you have to be careful. It's not quite the exact same process, but it is faster. If your first thing you're dividing by, if your divisor doesn't have like a 2 or a 3 or some number other than 1 in front of the variable. It has to be 1y or 1x or 1z or something like that. You cannot have a 2 or a 3 there. You can do synthetic division, but you have to make it all fractional first, and you don't want to do that. Because then you're multiplying and adding and subtracting fractions, and you don't want to do that. Okay? So what you would do instead is we can do synthetic division. Now, kind of set it up as a division problem. It's a little goofy. First thing you do is you want to set it up. So we start out, put a little couple of lines there, a little partial box. Okay. And then we do what we're dividing by, what we're doing the division by, per se. It's not exactly. Our variables are not going to be used. We're not going to have any variables in anything we do with this. So I'm dividing by y plus 5. Instead of putting 5 in here, I put the opposite. I put minus 5 in here. Okay, so I'm going to actually be doing my synthetic division with minus 5, not plus 5. I always do the opposite. Okay. And then next to this, working out horizontally, I write the coefficients that I have in front of my other variables. I have 4y squared plus 23y minus 16. No variables. Okay, this is your setup to do the synthetic division. Okay. Draw a line, leaving space to do work. Okay, you with me so far? Okay. This first number, you just bring it down. 4. Just take that first coefficient and bring it down. You don't make any changes. Now, here's where the process begins. You take the number out in front, -5, times the number down here, 4. So you multiply these two numbers, and you write it there. -5 times 4 is -20. Now, when we were doing long division, we subtracted. When we do synthetic division, we add. 23 plus -20 gives me what? Positive 3. Okay. Do the same thing again. Take the number out in front, -5, times 3. So -5 times 3 is -15. And then we add -31. This gives us our answer. This gives us our answer. What's the highest power we started with and what we're dividing into? Squared, y squared. Our answer is going to be start 1 power less than that. So we actually start, our final answer is going to be 4y, instead of y squared, 1 power less, plus 3. And then this answer right here, the number left at the end, that's our remainder. 4y plus 3 with a remainder of -31. And if you go back in your notes, we did this problem and got the exact same answer. We're doing it long division. Okay, this is one of the problems we did before. Okay. It's a little simpler if you understand the setup. Okay, so same thing on the next one. First thing I do, make myself a little box. What goes in that little box? -2, the opposite of what I'm dividing by. -2. And then across here, I write out the coefficients. So how many m cubes do I have? 1. I have to put the 1, and then 7 minus 5 minus 6. Those come from the original problem. Okay. To do my work, I draw a little line, bring the first one down. That's going to be the first number of my answer. Yes, ma'am.
Where did you think about 1 from again?
How many m cubes do I have?
1.
1. So I have a 1 there. I don't write 1 if I don't need to write 1, but because I no longer have variables, I have to write the 1. Does that make sense? It's like when you have x by itself, how many x's? You got 1x. Okay? So now I've basically done the easy part. Now I need to start doing my multiplication and addition. -2 times 1 gives me -2. Add those. 7 plus -2 is 5. -2 times 5 gives me -10. Add those. Get -15. -2 times -15 gives me 30. And add those, and I get 24. This number here at the end is my remainder. If that number is 0, I don't have a remainder, and it goes in evenly. Okay? If I have a number there, that's my remainder. The other parts are my answer. I started with a cube here, which means my first term is going to be m squared. It's always 1 less power than what my original one started with. So I get m squared plus 5m minus 15 with a remainder of 24. So I mean, it's simpler. It's a little easier. It's a little less involved. You can still screw up, but it's clean. Long division of the same problem, you've got a lot of crap written down, right? This you don't have the crap written down, but you have to be able to keep straight what you're doing. Does that make sense? You drop the variables, oh, it's a little cleaner, but you have to remember, oh, I got to put it back, and where am I at, and that kind of stuff. So it's a little more complicated, but it's cleaner. There's less work involved on the paper, but it requires a little more understanding. Almost all things that simplify something, they have a give and a take. It's easier to do the arithmetic. It's cleaner. You're making up less space, but it's a little more complicated to understand what you're doing. There's a trade-off for everything. Okay, does that make sense? I like synthetic division, but like I said, there's a trade-off. Let's do another one together. Okay. So, my little box. What goes in my little box? 3. Now, look what I'm dividing into. I got a problem, don't I? There's a couple of missing numbers. There's no n to the 4th. There's no n to the 1st. What do I have to do? I have to put a place marker in. Just like I did with the long division yesterday, I have to put a place marker in. So how many n to the 5th do I have? I have 1. How many n to the 4th do I have? 0 n to the 4th. I have to put that 0 in because I have to have a place marker for every power. And then I have -2 n cubes. How many n squareds do I have? I have a -1 n squared. And then how many n's do I have? A 0. And then I have to have the 2 at the end. I have to have place markers for missing powers just like I did with the long division. This is one of the problems we did earlier with long division. We had to put the 0 n to the 4th in there and the 0 n in our work. We have to do the same thing with synthetic division. Every power has to be represented. Here's a clue. You take whatever the power is, in this case it's 5, I need to have one more thing than the power I have. One more than whatever that power is. Because I have to have whatever it is to the 0 power, my constant at the end. So if I have n to the 5th, I need to have 6 numbers along here. If you back up here, we go, yeah, no, that was right. So we go back to here, y squared, that means I need to have 3 things. 1, 2, 3. To the 3rd, I need to have 4 things. 1, 2, 3, 4. Okay, one more than the power. I better have that many numbers, which means in this case, I had to put a couple of zeros in there. But then from there, it works the same. Bring down that first number. 3 times 1 is 3. Add, I get 3. 3 times 3 is 9. Add, I get 7. 3 times 7 is 21. Add, I get 20. 3 times 20 is 60. 0 plus 60, I get 60. And then 3 times 60 is 180. Add 2, I get 182. My remainder, my answer. I started with n to the 5th. That means I'm going to start my answer with n to the 4th. N to the 4th plus 3n cubed plus 7n squared plus 20n plus 60 with a remainder of 182. It's not terribly difficult, is it? It's not. But like I said, the process is cleaner, it's neater, but it's a little more complicated. Trade-off. Everything's got a trade-off. Okay? I want you to set the next one up. Just set it up first and foremost, then we'll go from there. Put the little box, what goes in the little box, and so on from there. Okay, just set it up. Don't worry about working it out. I want to make sure you get the setup right first. Yes, because it has to be in the order. So I have 4, 3, 2, oh, no v to the first. And then 6. It has to go because of how many of those we have. So, did you put the 0 in? Because you need to put a 0 in this one. Okay, the 0 because you have 0 v's. You have v to the 4th, v cubed, v squared. Oh, no v's. So I have 0 v to the first power, and then I have plus 6. Okay. And then you go ahead, bring it down. And remember, it's not that, you know, if you remember that, oh, it's times this, times everything down here, and then these rows get added together. Okay, then it's not too terribly, once you get the setup, bring the first one down, and then I multiply, add, multiply, add, multiply, add, multiply, add. Okay, so I multiply and add. Multiply and add. Multiply and add. Multiply and add. My last number is my remainder. All the rest are my coefficients. And my answer starts with 1 power less than I began with on my original problem. 2v cubed plus 3v squared minus 7v plus 7 with a remainder of -1. Okay. Question? Yes.
Number in the box, they always split from the
It's the opposite of what it, you know, it's whatever it is, the plus or minus, it's the opposite of that. That's probably the most difficult thing that gets missed, is changing the sign. And I have to stop and think, because I don't, you know, I use this when I teach this. I don't use it a lot. It does have its uses. Okay, we talked about the other day about, hey, how many factors are there of this? Can I find a factor of this? Well, it's actually pretty easy to figure out what the factors are. If you know what you're doing in synthetic division, makes it easy to find factors. Okay, rather than guess it, you can guess and check, but you have a way of checking and a way of guessing that eliminates that. Okay, do these two. Yeah. So you have 5 cubes, so you're going to have 4. So that means it goes in evenly remainder. No remainder. And you start with z squared. Z squared. You have no z's, so it'd be z squared minus 1. Yeah. And that's okay. You can have a 0 down at the bottom of one of your answers. That means you have a 0 coefficient for that term. That's okay. That actually just means it's kind of nice. Okay. So there's a big long gap because it's hard to stop it. I can't go back. You know, it's not like you can do the tape thing. Okay, so as I've been recording, and hopefully these shouldn't take as long, let's go ahead and do these ones together. So I set up my box, and I have -2, and then I have 2, 5, 7, -4. Draw my line, bring down the first number. -2 times 2, so that's 4. Add, I get 9. Multiply, -18. Add, I get -11. Multiply, that gives me 22. Add, I get 18. That's my remainder. So I get 2a squared plus 5a minus 11 with a remainder of 18. And the same thing on the next one. Oh, what did I do? What did I do? Should be -4. Ah! And what happens when you screw up when you're doing division? Everything after that screw up is wrong. -4, 1. Better?
Yeah.
Okay. So that's -2, which means that this is 5. So that's -10. So this is -14. Is that right?
Yeah.
Okay, good. Yeah. Yeah, I did that on purpose, right? Yeah. Yeah, you believe me, huh? Yeah, grades are coming up soon. You'll believe anything I say. 2a squared plus a plus 5 with a remainder of -14. Right? No matter what I say, you're going to agree with me because grades are coming up soon.
Yeah. Yeah.
Yeah, Miss Forrest, you're right. You're always right, Miss Forrest. There's nothing ever wrong. You never make any mistakes. Right? Okay, so inside I have -5. And then I have 1z cubed, 5z squared, -1 minus 5. No blanks to fill in. Bring that down. That gives me a 1 there. -5 plus 5, 0. 0, -1. -1 times 5 is 5. Bring it down. So I have a remainder of 0, which means it goes in evenly. Okay. And then I started with the z cubed, so my answer is going to be z squared, because I have 1z squared, 0z minus 1. So I have z squared minus 1.
Can we go back?
Yeah,
I thought it was in order.
it is in order. There is no z. Z squared, 0z minus 1. Z squared minus 1. There is no, it's a 0.
So it would be like z squared minus 1z.
No, because these line up with the powers. Z squared, z's, 1s, and then my remainders.
Okay.
Yeah. Okay? Okay, go ahead. Yeah, do this one here. Do the first one. Don't worry about the second one. Get it later. You can get it now or not. It will have to be done by the time you do your notes. But we still have to do, and I've got to change what we're doing up there. We're finishing this. We're also going to do the 5.7 notes today. Okay, and I want to make sure we have enough. And it shouldn't take a long time to do those. So do the first one. Don't worry about doing the second one. Okay, seeing how you're only doing one right now, we'll go ahead and do that. Set up my little box as a 2. And then I have 5h cubed, 8h squared, no h's, and a minus 60. Yes, you have to have a 0 in this one for your h's. Bring down the first one, 5. 2 times 5 is 10. Add them together, I get 18. 2 times 18 is 36. Add them together, I get 36. 2 times 36 is 72. Add those together, I get 12. That's my remainder. 5h squared plus 18h plus 36 with a remainder of 12. Piece of cake. Okay. So, synthetic division is nice for doing long division. Instead of doing long division, it's a nice substitute. Once again, the rules are you cannot have anything in front of the variable. It has to be a single variable. It would not, if this was 2h minus 2, it wouldn't work. If it was 3h minus 2, it wouldn't work. Okay, so if you have something like that, you have to do long division. Okay? You can't, but what would happen is this would be a fraction, and you'd multiply that times a fraction, then you'd have to add the fractions, and you multiply by fractions. You get the idea? It's ugly. Don't want to do that, trust me. But synthetic division actually has a better use, or I should say a way of simplifying things. Let's say I want to evaluate a polynomial for a particular value. I want to plug a number in for x, like we've been doing. Now with the quadratic, I'm just going to plug the number in. But if I got something like this, it's a lot more complicated. Okay, but I can use synthetic division. Now, if I'm not using synthetic division, if I want to know what p of negative 1 is, that means I take p of negative 1 is 7 times negative 1 to the 4th minus 6 times negative 1 cubed plus 4 times negative 1 squared minus 5 times negative 1 minus 9, and I got to figure that out. Now, with negative 1, it's not that hard. Okay, because negative 1 to the 4th is positive 1, so that's 7. Negative 1 cubed is negative 1, so negative 6, negative 1, ooh, that's plus 6. Negative 1 squared is positive 1, so I have to put the 4 in there, so that's plus 4. Negative 1 times negative 5 gives me plus 5, and then minus 9. And then I combine those up. Let's see, this becomes 0. So I get 13. It's not so bad. Negative 1. Not a big deal, right? Okay, figure out what p of 23 is. So you got to put 23 in. You got to take 23 to the 4th power times 7. It's kind of a pain. Okay, let's not make it p of 23. Let's just make it p of 6. It's a lot smaller than 23, right? You still got to take 6 to the 4th power times 7. Subtract that from 6 to the 6 times 6 cubed, and you got, see what I'm saying? Kind of a pain in the butt. But if I use synthetic division, I can shortcut it. I can use synthetic division to evaluate a polynomial. Okay? So if we look at this example here. Oh, come on. Doing this to me earlier today. Extend the page to give me room. All right. So I can use synthetic division. It's set up nearly the same. If I want to find out what p of 3 is, and p is this function, I set it up nearly identical. The only difference is I don't change the number here. I don't change the sign. I put in what I'm evaluating it at. I'm evaluating at 3. I put 3 in here. I do not put -3. I'm not doing actual division, but I'm using the process to do evaluation. The next part's exactly the same. I plug the coefficients in. Now I have 1x to the 5th and 0x to the 4th minus 2x cubed minus 1x plus 0x plus 2. I do have to put my zeros in just like I would otherwise. And now, yes?
Are these two not to be opposite?
No, they stay exactly the same. The only thing that's the opposite is the beginning. Okay? Now, I do the process. The rest of the process is the same. Bring the first one down, multiply, add, multiply, add, multiply, add, multiply, add. Same process. 3 times 1, 3, add, I get 3. 3 times 3 is 9, add, I get 7. 3 times 7 is 21, add, I get 20. 3 times 20 is 60, add, I get 60. 3 times 60 is 180, add, I get 182. When I am evaluating, here's the cool thing. I only care about that. All I care about is what I would be getting as my remainder. Okay? So what this tells me is P of 3 is 182. If I were to take 3 to the 5th power and then take 3 to the 3rd power times -2, add it to that, minus 3 squared plus 2, I work that all out, I get 182. The remainder, when I do this, is my evaluation. That's my answer. Okay, so I do the same process as synthetic division, but I just get this. If we were to, there we go. If we were to go back up here and do the same thing, bless you, and set this up, if we were to go back up here and set this up and say, okay, I put -1, and then I have 7, -6, 4, -5, -9, and I set it up and I do the whole thing, the number I get down here, that would be 13. That would be what I would evaluate. That's my evaluation. So it's an easy way. If I've got a complex number, this is an easy way of doing an evaluation of a polynomial. It only works with polynomials, but it is an easy way of evaluating polynomials. Now, for a quadratic, we're only got 2 things, x squared and mx. It's not really worth doing this. But if I got a bigger polynomial like this, yeah, it might be. Go pretty quick for you. Yes?
Is there a reason why if you add all these numbers and then double it, it would equal?
No, I think that's just luck. Depends upon the particular problem. Okay. Do this one. Don't worry about the second one down here because if I recall, that is, come on. There we go. Is this one. P of 3. P of 3. No. No. But do this one. Do it now. Okay, this shouldn't take too long. So when we do this, remember you don't change the sign. So I have -2 goes into 4, -1, 5, -1. Bring down the first term to 4. -2 times 4 is -8. Add them together, -9. 18, 5 plus 18 is 23. -2 times 23 is -46. Add them together, -47. So that means P of -2 is -47. Piece of cake. Easy peasy. It's a nice way of doing evaluations. If you got to evaluate a big polynomial, it's a nice way of doing a big polynomial. Like I said, if it were like 3x plus 2, I'm not doing this. If it's squared, I'm not doing it. Cubes, I probably wouldn't either. But I get higher than that, and I get an ugly number I'm putting in there, yeah, I might want to do that. Okay? I might want to do that. It helps it out. I think. Oh, So, I want you to do these two. Last two problems. Okay, evaluate using synthetic division. Okay, so we're doing -2, p of -2. Coefficients are 6, 3, -2, -5, -4. Bring down the first, I get 6. Multiply -12, add -9, multiply 18, add get 16, multiply -32, add, I get -37, multiply, I get 74, add, I get 70. So that means P of -2 is 70. Does that work out? Hope that's what you got. Okay, the next one, same idea. So I have -4 into 3, 6, 0. -7. Anybody forget the 0? Anybody going to admit that they missed the 0? I'm sure somebody did. But that's okay. It's not the end of the world. Extend the page. So I'll bring down the first one, 3. Actually, let's give myself a little more room to work. Bring down the 3. So I get -12. And I get 6. -24. -24. 4 times -24 is 96. Add them together, I get 89. So P of -4 is 89. God, these smart kids keep pointing out my stupid mistakes. All right. Okay. 24. 90. -96. And add them together, I get -103. So I was only off by a lot. Okay. So P of -4 is -103. Are we happy now?
No.
It's easy to screw up. It is. It's easy to screw up. You got to be more careful. When I fly through this, I make too many mistakes. So that's the end of that one, right?
Yeah.
Okay, let's take 5. I need to deal with